Okay, today we're going to look at solving inequalities with absolute value. So first off, we're going to solve inequalities the way we always do with absolute value. So we're going to start with just looking at the absolute value, and then we're going to look at some special cases. So let's look at a couple absolute values. First one, we'll have just things inside the absolute value. So maybe we have like 2x plus 2 is less than 3. And then we'll have stuff outside. So maybe we'll have 3 2x minus 5 plus 3 is greater than, well, we'll go with 6. Okay, so the first rule is if the inequality symbol is a less than or equal to, you're going to use the word and. If it is greater than or equal to, you're going to use the word or. So in this case, we're going to use the word and. On this case over here on the right, we're going to use the word or. So if it's less than or equal to, it's an and. If it's greater than or equal to, it's an or. All right, and now we're going to solve the whole thing. So, and this is true when the inequality is on the left. So if it's not, move it around so the inequality is on the left. So we're going to read this left to right, and we're going to do the absolute value like we normally do. We have two equations. You're going to have 2x plus 2 is 3, and we have 2x plus 2 is negative 3. And I purposely left out the equals because we're going to put inequality symbols this time. Now we need a word between them. It's less than, so it's going to be an and. And remember, absolute value on the sign before you can look at on the left side before you can look at the inequality symbol. Okay. Now the rule is on the first one, when it's positive, you're going to keep the symbol just the same way. Okay, because we're doing nothing special to it. So we have 2x plus 2 less than 3, just the way it is here. Now in the second one, when you went to the negative 3, you're using the opposite. And the way we got to the opposite is you multiplied by a negative 1. Now we didn't actually do it, but that's where it came from. And the rule is when you add or multiply or divide by a negative, you switch the sign, it still applies here. So this less than is going to become a greater than. So there's two things you're going to do. The first one is exactly the same. The second one, you're going to switch the sign, which also switches the symbol. And then you look at the inequality sign and determine if it's an and or an or. So we now have our two, and we're going to solve them separately, just like we did before. So solving this, we're going to subtract 2 from both sides. You get 2x is less than 1. Divide both sides by 2. In this case, x is less than 1/2. And, because that's the word that was in the middle, we're going to do the same thing on the left. Subtract 2 from both sides. We get 2x is greater than, it's negative 5. Divide both sides by 2. And you get x is greater than negative 5/2. So we got x is less than a half and x is greater than negative 5/2. So it ends up being that x is going to be between 1/2 and negative 5/2. So x is in the middle of these two numbers if we're going to graph it later. Okay, now if we have a more complex example, like over here, we first got to isolate the absolute value, which means we have to get rid of this 3 and this 3, just like we did with absolute value before. So we're going to deal with the plus or minus first, subtract 3 from both sides. You get 3 is times the absolute value of 2x minus 5 is greater than 3. Dividing both sides by 3. You get absolute value of 2x minus 5 is greater than 1. Now remember, if this had been a negative, we would have switched the symbol. Because it's a positive, it stays the same. Now we're going to treat absolute value just like we did over here. So we're going to write two equations. 2x minus 5 with a 1. 2x minus 5 with a negative 1. The original one keeps the original symbol. The one with the minus, you switch the symbol around. And we got to decide on the word in the middle. It's a greater than, and a greater than is an or. So we're going to have an or statement here. And now we're going to go ahead and solve both of these separately. So we're going to add 5 to both sides. You get 2x is greater than 6, and dividing both sides by 2, x is greater than 3. Or, over here, add 5 to both sides. You get 2x is less than 4. Negative 1 plus 5 is 4. Dividing both sides by 2, x is less than 2. So either x is bigger than 3, or it's going to be less than 2. So this is the case for absolute value when you have a positive number. But what if it's negative? Well, let's look at that case. So let's open up a new scratchpad here for me. Let's say that we do have negatives. Well, let's try one. So we got the absolute value of 2x plus 3 is less than negative 4. Well, before we said there's no solution, but you can't immediately say that because it's not an equal sign, it's a less than. So absolute value must be positive. There's no exceptions to it. A negative is clearly negative. So can a positive ever be smaller than a negative? This can never happen. So no matter what x is, this is going to be false. So we're going to say that it is no solution. So the case where its absolute value is less than a number, it will be no solution. But what if it's greater than? So let's look at this case. Let's switch it around, make it a greater than. This thing is positive, greater than a negative. Well, it doesn't matter what x is. This thing is always true. So this has all real numbers as a solution. Means every single real number is a solution. So you can have two cases when you have a negative on the other side. Either you're going to have a false statement when you use the less than symbol because this can never happen, so there's no solution. Or you can actually have everything happen because it doesn't matter what x is. Every single number works, so you have all real numbers. So take a look at these cases carefully. When you see that negative over here, don't immediately go to no solution like we do with the equal sign. If it was equal, it would also be no solution. Okay, if you got any questions, please make sure you ask.